Thank you for joining the December 2022 VMware TAM customer webinar. This webinar is organized by the VMware TAM organization to provide our customers the opportunity to hear great content and interact directly with great speakers that are delivering it, with the goal of making sure that you are getting the full benefit from your software. Please make use of the Q&A feature to ask any questions, and if your question doesn't get addressed today, be sure to reach out to your TAM and ask them to follow up. Before we get into the content, there are just a couple of announcements. Our next TAM customer webinar will be on January 19th, 2023, and we will have the privilege of being joined by Jad Alzine, a technology director for our cloud management group, to talk about the recently announced ARIA platform, specifically Hub and Graph. As I mentioned earlier, we want you to benefit from these sessions by interacting with the speaker. So if you have any questions during today's webinar, please use the Q&A feature of Zoom and we will address them during the webinar. At the end of today's session, you'll be prompted to fill out a survey related to the value you received from this session and any topic suggestions for future sessions. Your completion of this survey is a very valuable gift back to us. The information will be used to build the webinar schedule in 2023. And finally, this webinar is being recorded and your TAM can make the recording link available to you. After a few months, the recording will be publicly available on the VMware TAM Services YouTube channel. That brings us to today's speaker and topic. Féidhlim is a senior technical marketing architect with our cloud platform team and will be talking to us about what's new in vSphere 8. Féidhlim, please go ahead.
Thank you. Thank you for the introduction. So welcome everybody. My name is Féidhlim O'Leary, Senior Technical Marketing Architect here at VMware. And roughly over the next hour or so, we're going to look at a technical overview of what's new in vSphere 8. So this isn't the absolute be-all and end-all of what's new in vSphere 8. And for a lot more deeper dive content, we have more content available on core.vmware.com, which is where all the technical marketing team puts their content. There's a question already saying there's no sound. Is everybody able to hear me?
Yes, I can hear you.
Okay, so that might just be on that particular user's end. So the agenda for today is we're going to look at what's this vSphere Distributed Services Engine. So that's a term you may not be familiar with. We look at what's new in the areas of vSphere with Tanzu, Lifecycle Management, updates in the areas of AI and ML, guest OS workloads, resource management, and a little bit on security. So we'll dive right into the vSphere Distributed Services Engine. So you might have heard the term over the last couple of years of Project Monterey. And that's what the vSphere Distributed Services Engine has been born out of. It's been born out of this Project Monterey, which is where VMware and vSphere is looking to unlock the power of data processing units, or a DPU. And this will allow us to perform improved performance by using these hardware accelerators to boost the infrastructure performance. There's very simple DPU lifecycle management. We'll talk about that in a moment as well. And we have increased infrastructure security because of an isolation layer between a data processing unit and the rest of your vSphere environment. So if we were to put a look at today's vSphere environment, if we imagine that this picture was representing vSphere 7, a DPU would exist at the hardware layer, similar to any other PCIe device like a NIC or a GPU. And all our familiar vSphere services and NSX services all run on the x86 ESXi instance. So the x86 compute layer being virtualized by ESXi. And there's still a little bit of a hardware isolation there between ESXi and a DPU. So what we're actually doing in vSphere 8, we're actually putting another version of ESXi on the DPU itself. So we're installing a version of ESXi on the DPU running on the ARM processor directly on the DPU itself. And this allows us to offload vSphere services directly to the DPU for increased performance. And the first service that we're that we're offloading to the DPU in vSphere 8 is NSX services. So at Greenfield installations will be supported at GA with additional installation types coming later in future releases. Now, the vSphere Distributed Services Engine is lifecycle managed using vSphere Lifecycle Manager. You might be looking at this picture thinking, do I have double the number of ESXis that I need to manage and lifecycle? And realistically, the answer is no, because in vSphere Lifecycle Manager, any ESXi host that has a DPU installation will just appear as a child object, and vSphere Lifecycle Manager will automatically remediate both ESXi instances in the one remediation event. So they're always remediated and kept in version lockstep. And there is a question in the chat there around licensing. There is an additional licensing that is required for vSphere Distributed Services Engine, and it does require NSX at this point in time. I don't have the specifics around the actual licensing SKU. You could reach out to your TAM to follow up on that particular SKU. Now, once you have ESXi installed, and ESXi is installed on the DPU itself, it's very simple to activate the network offloads using a distributed switch version 8, and you've got NSX up and running. You simply select the drop-down and select the appropriate DPU that's installed in your environment. So initially at GA, we support DPUs from NVIDIA using the NVIDIA Bluefield or AMD Pensando. So with that enabled, network services will be offloaded to the DPU. So they will free up x86 CPU cycles, give you some resources back to your virtual machines, but also increase performance of those network services because they're being accelerated by the DPU itself. And you still maintain all the enhanced visibility of network traffic, security, isolation, and protection that you would expect from NSX. So we do have additional content on vSphere Distributed Services Engine and DPUs, again, on core.vmware.com. That goes into a little bit more detail. And in future releases, we are planning to add additional services to the DPU. But as I said, at GA, there is only the NSX network offload services. So that brings us to the vSphere with Tanzu updates. So we introduced vSphere with Tanzu. We re-architected vSphere in vSphere 7 to make it more Kubernetes native. You know, you can run native containerized applications with vSphere pods, but a lot of the value add came from the Tanzu Kubernetes Grid runtime, which is VMware's offering to provide a conformant, a Kubernetes upstream conformant Kubernetes clusters that are very easily deployed on vSphere. But we did have a little bit of a problem that we ended up with a couple of different Tanzu Kubernetes Grid offerings. There was Tanzu Kubernetes M, S, and maybe a couple of other iterations. So with vSphere 8, we're also introducing Tanzu Kubernetes Grid 2.0, which looks to consolidate all those various different offerings down to one single unified runtime from VMware. So it'll be the same runtime regardless of where you're running this, either on-prem, in the cloud, or wherever. We're also introducing a new vSphere 8 feature called Workload Availability Zones. And this is a way to spread, and we'll look at this in a future slide, but it's a way to essentially stretch your vSphere with Tanzu supervisor clusters, your namespaces, and your TKG clusters across multiple vSphere clusters. So right now in vSphere 7, you're kind of siloed into one cluster, but with vSphere zones, you'll be able to span multiple clusters. We're also bringing cluster class, which is a declarative way to specify the cluster's configuration through the open source cluster API project. We'll look at that as well in a future slide. As long as we have the Photon OS and Ubuntu base images, these can also now be customized and saved back into your content library for use in future Tanzu Kubernetes clusters. So you have some customization now over your base TKG images. And one big ask was around the area of identity management, and that's why we're bringing Pinniped integration to vSphere with Tanzu at both the supervisor cluster layer and the TKG layer. And Pinniped supports OIDC federated authentication, and there's absolutely no dependency on vCenter SSO when you're using Pinniped authentication. And we have a slide on that as well coming up. So I mentioned vSphere zones. So this diagram illustrates how vSphere zones would look and operate. So we have our three clusters, vSphere cluster 1, cluster 2, cluster 3. And initially at GA, each zone can represent one vSphere cluster. So we have three zones, we've got three clusters, and there's a one-to-one relationship initially. And it allows us then to deploy our vSphere Tanzu supervisor cluster across those three zones. So you'll have a supervisor cluster VM on each of the vSphere clusters. You can stretch your namespace across the zones and then deploy Tanzu Kubernetes grid clusters again and separate them out and distribute them across each of the vSphere zones. And this allows for increased availability. So you're no longer you no longer have a single point of failure where all your Tanzu Kubernetes clusters are living in one vSphere cluster. Now they can be distributed across multiple for increased availability and also increased resource consumption, because again, you're not locked into a single cluster that may have reached its maximum available size. You can now span across up to 3 vSphere clusters. Now you can still do the traditional method of a cluster deployment where the supervisor cluster and all your TKG clusters are located within one vSphere cluster, but you now have the option in vSphere 8 to also do a zoned deployment. Now, cluster class is an open source specification, and it's part of the open source cluster API project, which is just part of the Kubernetes infrastructure in general. And Cluster API defines a declarative way to lifecycle manage a Kubernetes cluster by using an existing management Kubernetes cluster. So we use a Kubernetes cluster to deploy and manage existing or additional Kubernetes clusters. So in vSphere with Tanzu, that management cluster is our supervisor cluster. And cluster class provides a declarative way to define the cluster's configuration, but now as well as the default installed packages. So a platform team can decide what packages or what pieces of software I want to be installed to my Tanzu Kubernetes clusters at cluster creation time. And this could include anything from network and storage packages, cloud provider packages, authentication mechanisms, metrics collection, whatever it may be, that can be defined as part of the cluster class specification. And it will enforce that any Tanzu Kubernetes clusters deployed with that cluster class will have those appropriate packages pre-installed. Now, in addition to having pre-installed packages, we also want to have the flexibility to add additional packages and customization where we see fit. And with that, we're bringing in the Tanzu package repository. So after cluster deployment, DevOps users can optionally add additional packages from the Tanzu package repository using the Tanzu CLI. So again, this could be anything from ingress, certificate management, different logging packages or observability packages. And these can all be managed as add-ons and made available through the Tanzu CLI interface. And the last major update in the vSphere Tanzu space that we'll talk about is the federated authentication with Pinniped. So in vSphere 7, as I mentioned, authentication was always performed through the integration with vCenter SSO. And you can still do that today in vSphere 8, but you now have an alternative. So with Pinniped integration, the supervisor cluster and Tanzu Kubernetes clusters will have OIDC identity providers without relying on vCenter single sign-on. And those pinniped pods are automatically spun up when you deploy your supervisor or you upgrade it to vSphere 8, and you upgrade your Tanzu Kubernetes clusters as well. So the diagram on screen just illustrates a simple or potential workflow, and it might be slightly different depending on the identity provider in question. So at number 1, the user will use the Tanzu CLI login to authenticate to the supervisor or the Tanzu Kubernetes cluster. The pinniped integration will federate out to a respective identity provider, and that identity provider will return a login link or a login window, whatever it may be, depending on the identity provider. The user will provide their credentials, and the successful authentication to the identity provider is returned to pinniped, and Tanzu CLI will build a kubeconfig file needed to access the supervisor or the Tanzu Kubernetes cluster, whatever you're authenticating to, and as long as you have the relevant permissions. So that's just a sample workflow or sample flow of how you would authenticate using pinniped integration. It might be slightly different depending on the identity provider in use, but the key takeaway here is that there's no dependency on vCenter single sign-on when using pinniped integration. SSO could be offline, vCenter could be offline, and you'd still be able to authenticate to your supervisor cluster or your Tanzu Kubernetes cluster. So we've removed some of the dependency there in terms of authentication. Now let's look at the updates in the areas of lifecycle management in vSphere 8. So these are just some of the bullet points, and we'll touch on some of these in a little bit more detail as well. We mentioned DPUs earlier, and DPUs have an installation of ESXi installed directly on them. And with vSphere 8, we'll be able to detect the hosts that have DPUs pre-installed, and we'll be able to lifecycle manage and remediate those hosts in one remediation event, and it'll remediate both instances of ESXi. So they're always kept in the same version. So we're also bringing back staging support and parallel remediation to vSphere Lifecycle Manager. These were things that are available when you're doing the VUM-based method of doing lifecycle management, but in our goal to get feature parity for the image-based way of doing things, we're now supporting staging and parallel remediation with Lifecycle Manager. We have a technical preview of something we call vSphere config profiles, and we'll touch on that as well in a moment. But in a nutshell, config profiles is going to be our next generation of cluster configuration management and a future replacement of host profiles. So don't worry, host profiles aren't going away in vSphere 8. But cluster configuration profiles will be the inevitable replacement once they're ready for full production use. Standalone host support comes to vSphere Lifecycle Manager as well via the vSphere APIs. And we've updated the VMware compatibility guide to list the features that a third-party hardware support manager is capable of. Things like staging, firmware support, firmware patching, parallel remediation, things like that as well. So we've got some updates from our third-party partners to let you know if their HSMs support the features of vSphere Lifecycle Manager. So just for your awareness, when it comes to Update Manager, vSphere 8 is the last release that will support the Update Manager way of doing things, and that could be called Baseline Managed Lifecycle as well. Now, it means that it's going to be there in vSphere 8, it's still there in vSphere 8, and it will be there for the full life cycle of vSphere 8. But vSphere 8 will be the last release that supports the baseline method of lifecycle managing your hosts and clusters, or the VUM-based or the Update Manager way of doing things. And in the next future major release, Update Manager will no longer be present. So as I mentioned, staging comes to vSphere Lifecycle Manager. And staging is actually quite an important feature, and it's great that it's back here in vSphere Lifecycle Manager, because it allows us, as the name suggests, pre-stage the update payloads down to the hosts in advance of remediation. And this is important for a couple of reasons. So it reduces the overall time needed that the hosts have to spend in maintenance mode. So you can stage the payloads without entering maintenance mode. You can also stage some firmware payloads down with the integration from a supported hardware support manager. And it's also useful in the event that we're running some edge hosts. So we've got hosts that may not have the best link between ESXi and vCenter. And in some cases, remediation may fail during live image transfer, for example. But with staging, we can pre-stage the payload down and ensure that all the update payload is now local to the ESXi host. And that ensures that the remediation event is far more unlikely to fail as a result. So it'll overall speed up the cluster remediation time, the host remediation time, and firmware payloads can also be staged as well. So some good updates there to quicken the life cycle of your vSphere clusters. The other major feature to quicken cluster remediation is parallel remediation. Now it kind of does what you might think, remediate multiple hosts in parallel, but we're doing it a little bit differently right now because we do have some work to do under the hood to make DRS a little bit more clever when it comes to placing multiple hosts in parallel. So the way it works in vSphere 8 and vSphere Lifecycle Manager is that the administrator, the onus is on the vSphere administrator to choose what hosts do we want to remediate in parallel, and the administrator must place those hosts into maintenance mode first. So that has to be a conscious manual decision that a vSphere administrator makes. And then once the hosts are in maintenance mode, you can enable parallel remediation, and all those hosts that are in maintenance mode will be remediated at the same time, rebooted at the same time, and get updated all at the same time. But it's important to note that only the hosts that are manually placed into maintenance mode at this moment will get remediated in parallel in this particular lifecycle operation. The reason for that, as I said, there is some work we need to do under the hood to make DRS a little bit more smarter, a little bit better at identifying when we're putting multiple hosts into maintenance mode to avoid VMs doing needless vmotions, multiple vmotions when we're doing a multi-host maintenance mode event.
Hey, Féidhlim, we've got a couple of questions that I think are relevant here.
Sure.
I see you're remediating in this screenshot a cluster at the cluster level. But there's a question if VLCM can initiate a remediation at the vCenter level to remediate all clusters.
No, so it typically will work at the cluster level for most of your operations, but VLCM can also do standalone hosts that are not in clusters, but there's no option to remediate an entire vCenter worth of clusters, for example. The highest level you can go to is at a cluster level.
Okay, and then I guess kind of a unrelated follow-up question. You mentioned that the baseline way of managing clusters will be going away, and that Ada will be the last version to support that, kind of replacing Update Manager. Someone asks if the VMware Update Manager download service will still be available. Is that something you could comment on?
Yes, that should still remain available. That is still available today to service the image, the single image way of doing things, or the VLCM way of doing things. It probably should get a name change from Update Manager download service to something like VLCM download service, but that functionality to do those sort of air-gapped environments will still need to remain in place. There is also a question that does offline ESXi upgrade still support 8 and above? Yes, so you'll still have the same methods of upgrading ESXi host by mounting an ISO over, or the physical CD, or over ILO or iDRAC or something like that, and upgrading hosts outside of VLCM. So those methods are also still going to be available. And I'm assuming that upgrading ESXi hosts from 7 to 8 will be simple if using single image managed clusters. Yeah, so that's actually a good call out. If you're currently running vSphere 7 and you're using the single imaged definition, to upgrade from 7 to 8 is pretty much as simple as selecting version 8 from that cluster image dropdown on your cluster, hitting save, and remediating the cluster. You don't have to worry about building upgrade baselines or anything like that. And there's a question as well, what is replacing baselines? vSphere Lifecycle Manager has replaced baselines using this single cluster image definition. So there's no more of a concept of baselines there. Just trying to get through the rest of these LCM questions before I move on to the next section. VLCM has API support and Power CLI support. Yeah, they should be available. If there's any gaps in the APIs, please do send feedback to your TAM so we can get those filled. And yes, offline ESXi upgrades will support 8 and above via the command line as well. There's another question about the Update Manager download service. Will it be made available as an appliance or still need to install on Linux or Windows? I would love to be able to tell you that we will deliver an appliance, because I've been trying to get that on the roadmap. But as far as I know right now, it's still going to be the same process of installing the binaries manually. But it is something our product management team are aware of, and we do bring it up quite often, that we would love to see a prepackaged Update Manager download, or I should say a VLCM download service appliance available. But unfortunately, I can't comment on whether or not that's going to materialize anytime soon. And just try and get some of these other ones. Will VLCM stage cluster updates support ESXi 7 or pre-staging 8 updates? So for staging and for parallel remediation, you need to be on 8 first. And then so future updates to vSphere 8, ESXi 8 update 1, for example, when that comes out, then you'll be able to use the staging and the parallel remediation. You can't use either of those features if the hosts are still on version 7. Okay, so we'll just move forward. We can come back to some of those questions towards the end as well to wrap up on those lifecycle questions. I think there's still a couple of those floating around. So the next slide, or a couple of slides, is around the area of lifecycle management, but it's more also around backup and restore. So traditionally, we look at vCenter as being the source of truth when it comes to the state of our environment, the settings, where all the objects exist, and things like that. And that's been the way we've done things for quite a while. But we've kind of learned, and you probably know yourself, that sometimes vCenter may not be the right place to look for the most up-to-date information. That in fact, information on the host or the clusters themselves may actually be the better source of truth. And so we're introducing what we call a distributed key value store that lives on the ESXi host, and it's distributed across all the hosts in the cluster. And vCenter has what we call the cluster state. And these two objects try and stay in sync with each other. And the reason for this is if there's any information that is out of date on vCenter, it will reconcile that with the latest known good information on the cluster itself. And this becomes important in the events of if vCenter is restored from backup. So for example, if you're not taking very frequent backups, you may end up in a situation where you have to restore from backup, and the backup might be a couple of days old, or it could be a couple of weeks old. And a lot could have changed in the environment between the time that the vCenter backup was actually taken and when you actually did the restore. So that's where the distributed key value store is going to come into play and help bridge that gap of missing data. So let's look at that in a kind of just a step-by-step diagram, and it might help you understand it a little bit more. So let's say we have a cluster of hosts, and we have vCenter server is managing those hosts. And we took a backup of vCenter on Monday, and then we added a host to the cluster on Tuesday, and that's represented by this orange host here. And then on Wednesday, there was a catastrophic issue. We had to restore vCenter from backup because the data store got deleted or something. So we couldn't recover vCenter, we had to restore it from backup. So the backup gets restored, but it's at a point in time where it had no knowledge of that orange host that we added on Tuesday. So it gets restored, and the cluster state will query the distributed key value store of this particular cluster and ask, what's new, what's missing? And so the distributed key value store will reconcile that missing information with vCenter, and now vCenter is made aware of the missing information. There's a comment in the chat there saying distributed key value store sounds a little bit like etcd. That is a fair comparison. It's not exactly etcd, but it's if you understand what etcd is in terms of clustering technology, it would be a fair comparison there. Now, the first thing that this will support in vSphere 8 is just the host cluster membership. So what hosts are members of what clusters. So if you've added or removed hosts during the time when the vCenter backup was taken and vCenter was restored, that information will get reconciled. And we're hoping to add additional settings and configuration to the distributed key value store as well. One of my aspects that I'm strongly pushing for is distributed switch information. I'm sure we've all been in the situation where we've had to restore a vCenter from backup and it doesn't have quite the right exact updated distributed switch information, and you get things out of sync, and it can be a little bit finicky to recover from. So that's one thing that we are pushing for, to get into the distributed key value store as well, to make those sort of events less of a problem. Now, this absolutely doesn't excuse or remove the need for frequent good vCenter backups. That's still very much a priority. This is to bridge the gap between when a backup was taken and when a restore event may have occurred. Now, let's talk about configuration profiles, or vSphere configuration profiles. So in vSphere 8 GA, we've introduced a technical preview of what we're calling vSphere configuration profiles. And you can think of this as the next evolution, or the future replacement of host profiles. Don't worry, again, host profiles are still there in vSphere 8. And they're going to stay in vSphere 8 until we can transition fully to vSphere configuration profiles. But the end result of both is the same. We want consistent cluster-wide configuration across all our hosts in a particular cluster. We typically want all hosts to have the same sort of config in their respective clusters. That's what vSphere configuration profiles aims to do, and that's what host profiles aimed to do as well. And we're just doing it a little bit differently here, because rather than worrying about managing these profile objects that you had to remember to attach to clusters or attach to hosts, the cluster vSphere configuration profile lives in the cluster object itself. So there's no special place in the UI like with host profiles that you need to go to. You go to the cluster object and the configuration tab, and there's an area for vSphere configuration profiles. So the configuration lives within the cluster object. Now you can export the cluster to a file, to a JSON file, and believe me, it's far more readable than what a host profile XML ever was. So it's actually quite straightforward to be able to read a vSphere configuration profile, make any edits that you may need to do, and then import the edited document as well. Things like configuration drift, as you would expect, are monitored, and you get notifications bubbled up to vCenter to tell you that a particular host is no longer compliant with the desired configuration, and you'll be able to remediate that configuration drift. Now at vSphere 8GA, as I said, this is a tech preview, and it does have some limitations. The biggest limitation out of the box right now is that it does not support distributed switches, but I believe that is coming in the next update. So if you are taking a look at this, you may have to use it in a test dev sort of environment. But please do use it and give us your feedback. That's why we released it as a technical preview, to get it into as many hands as possible and make it the best that it can be. There's a question on this, will VCF leverage these vSphere configuration profiles? That will be down to VCF itself. Typically, VCF bill of materials tends to lag a couple of months behind as to, let's say, what vSphere is currently at. So it may depend on when VCF consumes the vSphere 8 bill of materials, and whether or not they change their own workflows to support it. But there's no reason why they can't. Configuration profiles go down to the physical hardware level setting. No, it would be a vSphere ESXi settings. If there's anything that would require a BIOS level setting change, vSphere config profiles has no visibility into that. That would be something that you would have to go back to the hardware level for. This is purely for the ESXi configuration itself. And I'm just checking if there's any other ones here that I can quickly answer. Okay, we'll have to come back to some of those. I need to think about them. So that brings us to the end of the lifecycle piece. In the next section, we're going to talk on some enhancements that vSphere is making to make it easier to consume the necessary hardware to support workloads for artificial intelligence and machine learning. So we're not talking about any AI software that vSphere is providing. This is purely the infrastructure to consume the necessary hardware for certain applications. And the first thing we'll look at is what we call device groups. So a lot of the time, AI and ML workloads need access to physical hardware. They need access to things like GPUs or specialized NICs or other accelerators to be able to do the vast amount of computation that they require. And it can be a little bit cumbersome to understand, okay, what piece of hardware do I need to pass through to my virtual machine in the right configuration? And that's where device groups comes in. And it allows hardware vendors to define device groups that either share a direct interconnect, something like NVIDIA's NVLink, or hardware that share a common PCIe switch. And this allows the hardware vendors to define these device groups, and they'll be presented and be visible to vSphere as a single unit that you can attach to a virtual machine. So a user doesn't have the ability to define these device groups themselves. They're defined at the hardware layer and discovered by vSphere. So they'll be attached as a regular PCIe device, like you might be familiar with. You go into your virtual machine settings, add a new device, and device groups would show up if they're available in the hardware, and they'll see as access type group. So in this example, I think the first one is 2 NVIDIA GPUs with an NVLink interconnect, and the second one is 1 NVIDIA GPU and a ConnectX NIC that share the same PCI switch. So there's no change to the existing add new hardware device workflows, and DRS and HA are aware of these device groups for initial VM placement, or in the case of vSphere HA, if there's a hardware failure and the VM needs to fail over to another host, vSphere HA will try and ensure that the VM fails over onto a host that can satisfy the appropriate device group. Now, the other area of consuming physical hardware to virtual machines that we're introducing in vSphere 8, we call device virtualization extensions. So this is a new API that will allow our vendors to create new hardware-backed virtual devices. So in previous releases, VMs consuming physical hardware using direct path IO or dynamic direct path IO were limited in their mobility, or even using device groups that we just saw, that you don't get all the benefits of a virtual machine's mobility when you're consuming physical hardware like that. And device virtualization extensions will build on dynamic direct path IO with its new framework and API, so that the virtual machines consuming these hardware devices will be able to do things like live migration using vSphere vMotion. It'll support suspend and resume, and things like snapshots for both disk and memory. So how does this work? Well, the vendors will need to create a specific device virtualization extensions driver at the hardware level, so that'll be installed on ESXi. And for the virtual machine level, the virtual device level will also need to have a compatible DVX virtual device driver. Once those requirements are in place, the virtual machine now has a lot more freedom of mobility and can live migrate to another ESXi host with a compatible DVX driver without any downtime. So you get all those great benefits of vMotion, but you're still consuming physical hardware that's being passed through, for lack of a better term, to the virtual machine. Whereas in previous releases, even with dynamic direct path IO, you only had that for initial VM placement or vSphere HA failover. Now let's look at some of the updates in the areas of guest OS and workloads. So like any other vSphere release, we introduce a new hardware version. We're up to 20 with vSphere 8. We're introducing something called a virtual TPM provisioning policy, and we'll talk about that and how it'll help deploy our Windows 11 workloads at scale. We're helping those very sensitive applications become vMotion aware. Also updating our high latency sensitivity settings to now support hyperthreading. There's a simplified Pneuma configuration, and we'll look at some of the compute maximums that have gone up in this release. So the theme of our virtual hardware version 20 is virtualizing hardware innovations, guest services for application, and performance and scale. So this is some of the areas that we'll talk about. So in the areas of virtualizing hardware innovations, we're bringing the latest Intel and AMD CPU support. We're introducing device virtualization extensions, which we spoke about a moment ago. And we're increasing the number of direct path IO devices that could be presented to a VM. I think it was 8, but it's now 32 in vSphere 8. Under the banner of guest services for application, we're introducing a new features like vSphere datasets, which we'll talk about in a moment, application-aware migrations, which we'll also speak about, and as you'd expect, we're introducing the latest guest operating system support. Now, some of these operating systems were already supported in vSphere 7, but they didn't have their own dedicated dropdown. So you might see some new dropdowns in the new VM Wizard as well to give you those best practice and recommended defaults for those particular guest operating systems. In the areas of performance and scale, we're increasing the number of vGPUs from 4 to 8. We introduced device groups to help you very easily consume those physical hardware for your AI ML workloads. And we'll look at high latency sensitivity with hyperthreading as well in a moment. Now, I mentioned the virtual TPM provisioning policy and how this will help deploy Windows 11 at scale, but it can also be applied to any other workloads or any other operating system that leverages a vTPM device. But Windows 11 has a hard requirement that it requires a vTPM device or a TPM device to be present. And one of the challenges around that when we're talking about TPM devices revolves around cloning or deploying from templates, because when you clone a VM, you're getting an exact copy. And that can introduce some potential security risks. If you're cloning a vTPM device, any secrets that are stored in that vTPM device will also be cloned. So that's where the virtual TPM provisioning policy comes into place. During a clone or a deploy from template operation, you now have this new option during the wizard to either do a direct copy, maintain the status quo and do a direct copy of the virtual machine, but you'll also be given the option now to automatically replace the vTPM. And this will automatically make all subsequent clones have a unique TPM. Any secrets that may have been stored in that vTPM device on the source won't exist on the resulting clones. So for that reason, it's also important to plan your Windows 11 templates accordingly, that you're not consuming any features that may be leveraging a TPM device like Windows BitLocker or Windows Hello. Those OS level functionalities may break if you replace the TPM device. Now you have the option to copy or replace. You can change the default option as well using a vCenter advanced setting. The default is still copy, but you can change this screen to default to replace using a vCenter advanced setting. The OVF tool 4.5 has been updated to support what we call a vTPM device placeholder to allow for simpler export and import of virtual machines that need vTPM devices. We have a very verbose document up on core.vmware.com that goes into a lot of detail on everything to do with vTPMs and deploying and how they're used and how cloning and templates work with that as well. So I would urge you to check that out as well. It goes into a lot of detail around this. There's a question on this as well in the chat. Does cloning in version 7 only do copy of TPMs? Yes, there's no automatic replace function in vSphere 7. So if you copy or clone a virtual machine that has a vTPM device, you're doing an exact copy. You would have to manually remove the vTPM device and re-add a new vTPM device if you want to make, if you want your VMs to have unique TPM devices. Okay, so the next thing we'll look at is vSphere vMotion notifications. So we probably, might take vMotion for granted. It works pretty seamlessly, and most applications are completely unaware that they're being vMotioned. But there are certain applications that can't tolerate the stuns, even however brief they might be, with vSphere vMotion. So these applications can now be written to be migration aware or have little child applications written to be aware of the impending vMotion. So we can write a little application that will intercept a notification. When a vMotion event is triggered in vCenter, a notification is sent from ESXi to the virtual machine itself. And it's done, it's intercepted using VMware tools. And the application can then either do some work to prepare for the vMotion event. This could be something like stopping services, performing a graceful failover in the case of a clustered application, doing some quiescing operation. Whatever it might be, the application now has been told there's a vMotion event pending. You now have X seconds or X minutes to perform whatever work you need to do before the vMotion event actually begins. So the application can delay the start of the migration up until a configured timeout, but it won't be able to completely decline or prevent the migration from occurring. So you could either rewrite or write your applications to support vMotion notifications, or a partner application could be written as an intermediary to intercept the vMotion notifications and then in turn communicate with the main application within the virtual machine. So some of the use cases for this can include very time-sensitive applications, voice over IP applications where the vMotion stuns could cause calls to drop, or clustered or high available applications where the stun times may inadvertently trigger a high availability event or a failover event if heartbeats, for example, just are lost during the vMotion event. So this allows for greater support for certain very niche, very sensitive applications to now be aware that vMotion events are going to take place and they can behave accordingly and provide better resiliency. One important aspect to take away as well is that when you turn this on for a particular virtual machine, so it is done on a per VM level, that particular virtual machine then is excluded from automatic DRS load balancing migrations. So that's also an important aspect as well to take away.
There are a couple of questions related to that, both of them kind of at their core are, is this a future thing? Like we've put in some plumbing so people can write to this, or are there any applications that are aware of this today?
I'm not aware of any applications that are aware out of the box today. The plumbing is there, the APIs are all there. And you could write something like a Python application to be the intermediary today if you wish. But I don't believe there's any application that is aware of this out of the box at this point in time. Again, if you look on core.vmware.com, we do have an article that goes into a little bit more detail on this as well, with a demo that's using a sample Python application. Okay, so next we'll talk about our improved latency sensitivity settings. So in vSphere 7, maybe 6.7, I can't remember now exactly, we introduced some latency sensitivity settings. We have normal, we have high, and now we have high with hyperthreading. And basically all this means is that with high latency sensitivity with hyperthreading, the virtual machine vCPUs are scheduled on the same hyperthreaded physical core. So in the diagram on screen, we've got a virtual machine with two vCPUs, and we've got two cores represented here of our CPU, and they're hyperthreaded cores. So they've got hyperthread 1, hyperthread 2 on each of the cores. And with latency sensitivity with hyperthreading enabled, where possible, we'll always try and schedule the two vCPUs of the VM on the same core. If we didn't have this setting enabled, a vCPU 0, for example, could be scheduled on core 0, and vCPU 1 for the virtual machine could have been scheduled on core 1 or core 2 or core 7. But with this setting, we try and maintain that they are always scheduled on the same hyper-threaded core. This is a feature that requires hardware version 20 as well to take advantage of, and it's very easily turned on in the VM settings under the latency sensitivity section. Now, in addition to that, we also have some improved Pneuma configuration abilities. So vNeuma isn't anything new. It's existed since vSphere 5 days, but up until now, manually controlling vNeuma topology required the use of advanced parameters in the VM settings or using the CLI on ESXi host itself. But with vSphere 8 and hardware version 20, we now expose the vNeuma topology or the CPU topology right up into the vSphere client. So you'll have a summary tab, and you'll also be able to edit the cores per socket and the Pneuma nodes, and also do virtual device assignments to particular Pneuma nodes. Again, we do have, there is a lot more information on vNeuma and how to get the best out of the Pneuma topology as well. If you actually look up Frank Denneman's blog, he's got a couple of great articles, extremely detailed, that go into a lot more detail on the nuances around device assignment for the virtual devices. Okay, so the last topic in this section is vSphere datasets. So vSphere datasets is an API-driven method to be able to distribute small, infrequently changing data between the vSphere management layer and a guest operating system that's running VMware tools. And some of the use cases for this may include things like guest deployment status, some agent configuration, maybe inventory management, whatever it may be. We can now very easily share data and share information between the vSphere management layer and the guest operating system layer. This was previously possible with some virtual machine. The name of it is blanking on me, but they were not persistent when the VM moved or potentially power cycled. And that's one of the benefits of vSphere datasets, is that it lives with the VM object. It'll move with the virtual machine if it's migrated across hosts, clusters, or even vCenter instances. So the vSphere dataset file will be stored with the virtual machine. It can be interacted with from the vSphere level, even when the VM is powered off. You have full control over permissions from both the vSphere admin side and the guest operating system side. So you can completely disallow the guest operating system from interacting with data sets as well, for example. So it has better scalability because it's leveraging the secure vSphere APIs. You can have multiple data sets per virtual machine, and the data is persistent. You also have some advanced settings where you can choose for the data not to persist or not to persist in the event of snapshot operations, for example, or clone operations. We also have a very detailed article on vSphere datasets, as well as explanations of all the various APIs, how to use them, how they look, again on core.vmware.com. Now, just some of the scalability numbers here in vSphere 8. There's not a huge leap compared to vSphere 7. Just take that with a grain of salt, that we are continuously working on the scalability numbers, and we'll always try and improve them. We're now able to manage 96 hosts per vSphere Lifecycle Manager cluster. So previously VLCM had a little bit of a limitation on the cluster size. It can now do the full 96 host cluster size, with vSAN clusters still at their maximum of 64 hosts. We're upping the number of virtual machines per cluster to 10,000, and we're increasing the number of these vGPU resources that we support in a virtual machine. So just a little bit of a side-by-side, so you can kind of see that there isn't a huge difference between the vSphere 7 Update 3 maximums and the vSphere 8 maximums. Just keep in mind that we are continuously doing scalability testing, and we will look to iteratively improve on these in future update releases as well. So always check back at the config.max.vmware.com for the latest scalability maximums. Now, just two more short sections, and then we can delve into a little bit more on the Q&A side. So two enhancements in the area of resource management. The first being an improvement to the DRS algorithm with regards to memory usage. So we're introducing vSphere memory monitoring and remediation version 2, we're calling it. But it's part of the DRS algorithm. So we introduced memory monitoring and remediation in vSphere 7. And it looks at the running statistics of the virtual machine memory in terms of bandwidth, also the host memory bandwidth and things like that. So in vSphere 8, the DRS performance can be improved by leveraging these better memory statistics. It's a better algorithm for optimal placement decisions for those VMs depending on their memory usage. So it's just an improvement to the DRS algorithm to take into account better statistics for memory usage. The second thing in this area is vSphere Green metrics. So we're introducing new metrics, 3 new metrics that will allow you to monitor the energy and carbon equivalent emissions of your vSphere infrastructure and the workloads of the vSphere infrastructure. So the 3 new metrics we have are power capacity usage VM, so how much power is being attributed to a particular virtual machine workload, power capacity usage system, so how much power is the host using that is not directly attributed to virtual machines, and the power capacity usage idle, how much is the host using by just existing and not doing any, running any workloads, for example. It could be in maintenance mode. And with these metrics and your respective, energy provider and things like that, you'll be able to calculate the energy efficiency or the carbon equivalent emissions of your vSphere infrastructure. And you can also use VMware Area Operations Manager to ingest these metrics and visualize and predict the intensity and emission rates of various clusters or vCenter instances, and be able to observe that at certain times or certain data centers are using less energy or more energy depending on your environment. Okay, so the last couple of slides now is just on security. There's not a huge amount to go into security, and I guess that's a good thing, because with each version of vSphere, we're always making lots of incremental improvements to security features and controls. So vSphere 8 builds on our virtual SGX support to take advantage of the latest updates from Intel. vSphere 8 is only going to speak in TLS 1.2. We don't have support for TLS 1.3 at this point in time. That's usually a question that crops up around now. In previous releases, you could fall back to TLS 1.1 and 1.0, but in vSphere 8, that's no longer going to be supported. So everything will have to use as support TLS 1.2. One of the biggest things we've done is to make it so that executables cannot run on ESXi unless they've been installed from a certified signed VIB or signed package. Now this is configurable, but we've made it so that if you do shut this feature off, you'll get a big undismissible alarm. So that's a major clue that someone may be doing something undesirable and trying to install something on ESXi that may not be a certified VIB. We always recommend that you leave SSH disabled unless you're doing troubleshooting or working with support. And to encourage that, we have an automatic timeout by default, but that is again configurable. You can configure that and disable the timeout if you don't want it to interfere with actual work that you do genuinely need SSH enabled for. And just in general, we've making vSphere more secure out of the box. A lot of the defaults now out of the box fall in line with the vSphere security configuration guide. But if you do want to take a look at the vSphere security configuration guide, you can check it out at the following link. It's now part of the vSphere documentation too, or you'll be able to find it on core.vmware.com. So that just brings us to a wrap up. I'll just advertise a couple of other useful resources, and then we can try and scrub through some more questions if we have time. We have our VMware vSphere YouTube channel. That's where you'll actually be able to find a recording of this exact presentation, as well as a whole load of other presentations. And we have breakout chats. We have a stream called vSphere Live, where it's like a round table or a meet the experts. For everything security, I'd advise you to subscribe to our VMware security advisories. These advisories go out for all our products, so not just vSphere. And then for everything tech marketing related, check out core.vmware.com. We have specific landing page there for vSphere 8, so you'll be able to jump in there, hit the vSphere 8 tab, and everything that's relevant to vSphere 8 should show up there for you as well. So that's the end of the presentation. I'm just going to try and scrub through some of the questions. Do we have time, Brian, for questions?
Yeah, if you do, we can keep the recording going.
Okay, cool. So I'm just going to work from the bottom up. So SSH service, yes, will be disabled automatically out of the box by default, but that is configurable, and you can turn off that automatic disablement as well if you're doing troubleshooting or working with support, for example. Are we going to do two-factor authentication vSphere at some point? We are at some point. I don't have a roadmap for that right now, but we do support Microsoft ADFS, and then whatever ADFS may support beyond that, we have that integration. I would encourage you to reach out to your TAM if you want more of an in-depth look at the two-factor authentication roadmap. They can put you in touch with the product management team. Can you confirm if VMFS 5 is supported on vSphere 8? I don't know off the top of my head, but we can check. I'd need to have a quick look at a lab to see if that is supported, or you can reach out to your TAM to just double check a live lab if they have one handy. Any update to way DRS handles vGPUs? We still see failover issues with our VDI environment running grid. I'm not aware of updates off the top of my head. I know we're continuously working with NVIDIA to make the vGPU workloads better and less susceptible to issues with vMotion, but I don't have a more detailed answer for that, I'm afraid. Use cases for data sets, it could be anything from guest inventory, some agent configuration, even just some reporting information that you may want to share between the vSphere management layer and a guest operating system. Again, if you check out core.vmware.com, we have a comprehensive document on vSphere data sets that goes into some of the use cases in a little bit more detail as well. Any scheduler changes in the latest 7 update 3 or 8.0 with regards to side channel aware scheduler? Not that I'm aware of. I think we're pretty much done in terms of our recommendations there, and any additional updates, I have not seen anything that's specific to vSphere 8 GA with regards to things like Spectre or Meltdown. Any new upgrade to admission control for vSphere 8? No, admission control in vSphere 8 will operate the same as it does in vSphere 7. So you made a good point. If you're doing multiple ESXi upgrades in parallel, you may run into capacity issues if admission control is turned on, you may have to either temporarily turn off admission control or reduce the strictness of admission control. It may limit the maximum number of hosts you'll be able to place into maintenance mode. Are we going to consolidate how we license our applications? Every single application has a different method, and it's enough to drive somebody nuts. Unfortunately, I don't see that changing to a centralized licensing. There may be some improvements there with the likes of vSphere Plus, vSAM Plus, as things start moving to that subscription offering. But for on-prem licensing, every product team does their own little thing in that regard. So unfortunately, I don't see there being a consolidation in that regards. Can vCenter resource pool changes, restore resource pool changes after restore using DKVS? Not initially, but that is a good data point to include into the distributed key value store. But at GA, at 8.0 GA, it's only host cluster membership. What will happen in the event of a DPU hardware failure? That would be similar to what would happen if any piece of hardware failed in an ESXi host. It's likely to cause the host to PSOD or to crash. So we don't. There's hardware failures are something that we will just have to respond to as always. Is there plan to have certificates managed centrally? For vSphere, we are doing work to manage those certificates centrally. You can do most of them now from the vSphere client, but to centrally manage other products that may leverage vSphere, again, similar to the licensing question we had earlier, there's no central overseer for all products that might be in an environment. But vSphere certificates can be managed from vSphere, from a single vSphere instance. What are the use cases for configuration profiles when compared to host profiles? So the use case is pretty much identical. It's to have consistent configuration across all hosts in your cluster. So the end goal of both is the same. It's just how we're doing that with configuration profiles is a little bit different to host profiles. We're leveraging new APIs from the ESXi config store as well when using configuration profiles. And there's no specific profile or document that you need to manage. It's contained within the cluster object itself. But the use case for both is essentially the same, to have the consistent configuration on your hosts. Let's scroll up to some of the ones at the earlier. Hardware failure, we answered that. Yeah, so for quicker cluster remediation, when we're talking about VLCM and parallel remediation, it does depend on how many hosts you can afford to place into maintenance mode at any given one time. So for example, if you had a cluster of 20 hosts, and you know that you can account for 5 hosts being in maintenance mode at any given moment, you would only have to, you would be able to parallel remediate 5 hosts at a time, rather than doing the 20 all individually and in a serial fashion. Is deploying vendor-specific images no longer a best practice? No, that's still very much a reality, and that's why vendors have moved or have worked with us through the evolution of vSphere Lifecycle Manager to deploy what we call the vendor add-ons. So you can do it in one of two ways. You can use the vendor image, which is essentially an all-encapsulating image that has the ESXi base image and the vendor-specific components. Or you can build the image in vSphere Lifecycle Manager using the let's say the vanilla ESXi image, and then add the vendor add-on. So you can do it one of two ways, but the vendor-specific images are still available and are still very much a thing. And he plans to integrate vRealize LCM with vSphere LCM. I'm not familiar with vRealize LCM and what use cases it satisfies, but vSphere LCM is intended to lifecycle manage ESXi hosts. So that's its goal, that's its primary function. I'm not aware of any integrations between other LCM products. There are APIs available for vSphere Lifecycle Manager, so other products can leverage those APIs if they do wish to integrate as well. When using VLCM cluster management, does this require all hosts to be of identical hardware? This is a slightly grayish area. So of identical vendor, typically yes. So where possible, VLCM works best when your clusters are homogeneous, where they're from the same vendor. But there is some wiggle room in terms of the exact vendor model. So as long as they're not, generations apart, wildly apart, you can have clusters of mixed model from the same vendor. The reason for that is VLCM currently only supports one vendor add-on. So, if you have a mix of Dell and HPE, you can only add one vendor add-on. So if you add the HPE vendor add-on, that's not going to be compatible with the Dell host and vice versa. Similarly, with hardware support managers, it's one hardware support manager per cluster. Now that may or may not change in the future. I don't really have an answer for that, but currently we do generally expect that the clusters are of identical vendor and as close as hardware model as they can be. With integrated Windows authentication being deprecated and ADFS being the likely option, can you comment on enhanced link mode compatibility with ADFS in vSphere 8? So integrated Windows authentication did not actually end up getting removed in vSphere 8. It's still available in vSphere 8, but it's not recommended. You can still use it, but we prefer either ADFS or AD over LDAP. I'm not aware of any enhanced link mode issues when using ADFS in vSphere 8. So if whoever asked that question, if you can maybe reach out to your TAM and maybe explain a little bit more detail there on that. But as far as I'm aware, enhanced link mode and ADFS should be fine.
So many questions. I think you've made it through most of them. There's a few new ones that trickled in at the bottom.
But
I may.
Okay.
I was going to say we may stop the recording. We can leave the bridge open for some other questions. But really appreciate all of the time you spent today with the presentation and going through the questions. As we mentioned at the beginning, the session was recorded. Your TAM will be able to make that recording available to you. Please join us next month when we will be looking at ARIA Hub and Graph. We look forward to seeing you in the new year on January 19th. Thanks.